All right, today we're going on a cosmic hunt. We're looking for the absolute coldest place in the entire universe. I mean, a point so frigid it actually makes deep space seem, well, kind of warm. A place where the laws of physics themselves start to get wonderfully weird. So where would you even start to look, right? Maybe the deepest, darkest void between galaxies, some frozen, forgotten corner of space? Well, I'm going to tell you right now, the answer is probably not what you're thinking. But before we get to that surprise, we need to talk about what cold really is and what its ultimate limit is. Okay, so that limit, it's called absolute zero. On the Kelvin scale, that's just zero. It's this theoretical point where all the classical motion of molecules, all that jiggling and vibrating that creates heat, just stops. It's the ultimate stillness. It is the end of temperature as we know it. Now, you might think the vacuum of space is at absolute zero, but it's not. The whole universe has a kind of baseline temperature. It's about 2.725 Kelvin. And what is that? Well, it's the faint leftover heat from the Big Bang itself. We call it the cosmic microwave background. So even the emptiest parts of space are actually sitting at a relatively balmy 2.7 degrees above the ultimate cold. Okay, so that's the background temperature. But can nature get colder than that cosmic hum? Oh, you bet it can. Let's meet the long-reigning champion of natural cold. So we're traveling about 5,000 light years away to the constellation Centaurus. What you're looking at is the Boomerang Nebula. And it's not just gorgeous, it's basically a cosmic refrigerator. What you're seeing is what's left of a dying star that's been blasting its outer layers out into space. And this is the secret to its incredible cold. That dying star is ejecting gas at a mind-blowing 164 kilometers per second. And because that gas is expanding so incredibly fast, it cools down dramatically. It's the exact same principle as when you use a can of compressed air and the can gets super cold. That process is called adiabatic cooling. The gas is losing heat way faster than it can absorb any new heat from the space around it. So how cold are we talking? Well, it gets down to a staggering 1 Kelvin. Just a single degree above absolute zero. That is way, way colder than the background radiation of the universe. And for a really long time, this was the record holder. For decades, scientists were pretty sure the Boomerang Nebula was the coldest natural place we had ever found. Now, pay close attention to that word I just used, natural. Because, this is where the story takes a huge plot twist. The search for the ultimate cold doesn't end 5,000 light years away. It ends right here, on Earth. You heard me right. The single coldest spot in the entire known universe isn't some distant nebula or a cosmic void. It's something we made. It was created inside a laboratory. I mean, this quote really puts it into perspective, doesn't it? We, humans, have managed to engineer an environment that is colder than anything nature has cooked up in 13.8 billion years. Which just leads to the question, how on earth did we manage to do that? Well, it's not one single magic trick. It's actually a brilliant multi-stage process that pushes atoms right to the very edge of stillness. So let's break it down. Okay, so scientists use this really cool combination of methods. It all starts with lasers. Yeah, lasers. Then they use a process that's a lot like a cup of coffee cooling down. And the whole time, they're holding these atoms in a magnetic trap, so they literally can't touch anything and warm back up. Let's dive into those first two steps, because they're wild. First up, laser cooling. I mean, this is just incredible. Picture an atom moving around. Now, imagine bombarding it with photons, tiny particles of light from every single direction. Each little hit is like a tiny break, slowing the atom down, stripping away its energy, and making it colder and colder. Then, once they're pretty chill, comes evaporative cooling. This is that coffee analogy. You just let the hottest, most energetic atoms escape from the trap. Kind of like how steam carries heat away from your cup. What you're left with is an even colder group of atoms. Now, when you get atoms this cold, something truly bizarre happens. They enter a whole new state of matter. The fifth state of matter, in fact, which was first created back in 1995. It's called a Bose-Einstein condensate. The individual atoms, they basically lose their identities. They all start acting like one single, unified quantum superatom. It's in this totally exotic state that the world record was set. And what a record it is. In 2021, a team in Bremen, Germany, achieved a temperature of just 38 picokelvin. Let me try to put that into words. A picokelvin is a trillionth of a Kelvin. So we're talking 38 trillionths of a degree above absolute zero. It's a number so small, it's honestly hard for our brains to even process. So let's really put that into perspective. Remember the Boomerang Nebula, the coldest natural place in the universe? That was 1 Kelvin. This new lab record, it's about 26 billion times colder. That is just, it's mind-boggling. Okay, which brings us to the big question, right? Why? Why go to all this trouble just to break a cosmic temperature record? Is it just for bragging rights? Well, no. It's about way, way more than that. You see, studying matter in this ultra-cold state unlocks some incredible technologies. We're talking about the world's most accurate atomic clocks. These aren't just for telling time. They're the absolute bedrock of things we use every day, like GPS and our entire global communication network. This research also lets us test the fundamental laws of physics with ridiculous accuracy, and even simulate things like the inside of a neutron star. And maybe most importantly, it's pushing the frontiers of quantum computing, which, well, that could change everything. So we've gotten fantastically, unbelievably close to absolute zero. But this brings up one last really crucial question. Can we ever actually reach it? Can we get to zero? And the answer, believe it or not, is no. And it's not because our technology isn't good enough. It's because of a fundamental law of the universe, the third law of thermodynamics. It basically states that reaching absolute zero is impossible. Think of it like this. Each step you take to cool something down gets you closer, but the steps get smaller and smaller. You're always getting halfway there, but you can never actually arrive. You need an infinite number of steps to reach zero. It's a finish line we can get closer and closer to forever, but we can never actually cross it. And for me, that's maybe the most profound takeaway from all of this. Just think about it. In a tiny little chamber in a lab, for just a few moments, we humans have created a pocket of the universe that is more extreme, more fundamentally still than anything the cosmos itself has made in 13.8 billion years. It just makes you wonder, doesn't it? If we can engineer the ultimate cold right here on Earth, what other universal extremes are within our reach? What other cosmic limits are we on the verge of breaking? What else is out there, waiting for us not just to find, but to create ourselves?